Hello everyone. Last time we discussed about the resistors and the resistance. This time we are going to talk about, today we are going to talk about combination of resistors. Okay, so how can we connect the resistors? How can we combine the resistors? Let us try to understand that. Now there are two ways to combine the resistors. One way is series combination. Okay, one way is series combination and the other way is parallel combination. So these are two ways by which the resistors are connected, series and parallel. So let us try to understand them one by one. Okay, so the first way is shown here, series combination. Let's try to understand this. Now see, in series combination what we are trying to do is, here you can see that this is the first arm of the first resistor and this is the second arm of the first resistor. So what is done here is, as you can see, that the second arm of the first resistor is connected with the first arm of the second resistor. Okay, then the second arm of the second resistor is connected with the first arm of the third resistor and so on. Okay, so in childhood we used to play that game which we used to call train game. Okay, or that what we used to call chain game. Okay, in that we used to hold hands like this. So this is nothing but the chain game, you can say. Okay, so this is the chain game which is going on. Now here you can see that we have a potential source. Its potential difference is Vs. So we are creating, we can write V also, that's not a problem. So we are creating a potential difference of V across the two ends A and B. Okay, so these are the two ends A and B and we are creating a potential difference capital V between these two ends. Now I want you to understand this. This is extremely important to understand that what is happening here. You see that when the current flows, of course the current will flow. Now current flows, when current flows, see this current is coming out from here, and as it is mentioned here that it is the I current which is coming out. So I current is coming out and you see there is no other way, there is no other path through which this current can be divided. So what will happen, that this current will flow through these resistors only. There is no other way, isn't it? So what will happen, that the same current will flow through this R1 resistor, same current would flow through this R2 resistor, same current would flow through this R3 resistor and so on, and then it will reach here and it will return back to the potential V. Okay, so, or you can say the cell. So what is happening, that the same current is flowing through the circuit, R1, R2, R3, these are the resistors. Now try to understand this, that when this I current is flowing, why this I current is flowing, how can we decide this? Do remember that to decide this, actually the resultant of the series combination is used. Okay, it is not the individual resistor which is deciding that I current is flowing out of this cell. Okay, so what is happening is that combination of R1, R2 and R3, and that too series combination of R1, R2 and R3 is actually deciding that how much current would come out of this cell. Okay, and that's what we are trying to find in this, we are trying to find out in this particular circuit. Okay, that what is the series combination and what is the resultant of the series combination of these resistors. Now you see that when I current flows through this R1, so there is a potential difference of V1 created here. Then comes R2 resistor and there is a potential difference of V2 is produced here across the ends of the resistor R2. And similarly, when I current flows through this resistance R3, V3 is the potential difference which is created. Now do remember that between these 2 points A and B, there is a potential difference of V. Okay, there is a potential difference of V which is created. Now you know that this V has to be equal to V1 plus V2 plus V3, isn't it? because this V is ultimately getting divided into V1, V2 and V3, right? So we can say this, that V is equals to V1 plus V2 plus V3. Yes, V is equal to V1 plus V2 plus V3, right? Now what you can do here is you can write that this is equation, just a minute, this is equation number 1. Okay, this is equation number 1. Let us apply Ohm's law in these resistors. Okay, let us apply it in R1. So when we apply Ohm's law in this resistor, then we can write V1 is equal to IR1, because you know that the potential difference is V1 and current flowing is I and resistance is R1. So V1 is equals to I times R1. Similarly, when we write V2, so V2 would be IR2, correct or not? Because you see why we have taken same current, because you know that same current is flowing through all these resistors. The current is not different, correct or not? So V2 equals to IR2, and then comes V3, and V3 is equal to IR3. Now these values we can substitute here. Okay, we have value of V1, V2, V3, all these values we have, but we also need value of V. So do remember that V is the potential difference across the ends A and B. Okay, between these 2 points, the potential difference V is created by this cell or battery. So do remember that this V should be equal to, current is I only, but resistance should be the series combination of resistors. Okay, RS. It should be the series combination of resistor RS, because you know that these resistors are connected in series and their series combination will only decide that how much current is coming out. Okay, now when we have done this, let us substitute these values here in equation number 1. So what I am going to do is I am going to rewrite these equations here. V is equal to V1 plus V2 plus V3. Okay, let's substitute these values. You know that value of V we just now wrote, that V is equals to IRS is equals to IR1 plus IR2 plus IR3. All these values we substituted. Now you can take I common. When we take I common, you can write here I into RS is equal to I common, and you will be getting R1 plus R2 plus R3, correct? And this I and I is cancelled. So what is left now is, this implies RS is equal to R1 plus R2 plus R3. So the series combination of resistors, resultant resistance of series combination of resistors is RS is equals to R1 plus R2 plus R3. So basically, when you want to find the series combination of resistors, what you have to do, you have to simply add these resistors and you will get the series combination of resistors. So this is the answer. Now some important points. Do remember that in series combination of resistors, current I remains constant. Current I remains constant. Okay, I remains constant, right? I remains constant. Having said that, do remember that if I remains constant, okay, because there is no other path which is provided here, okay, to the current, and that's why current will flow through this particular path only, and same current would flow through all the resistors. Next is the potential difference. Do remember that potential difference V, it gets divided. Okay, so these are two important points which one must know when we are talking about the series combination of resistors. I remains constant and V, it gets divided. Hope that this is clear to you all. Okay, then we'll be talking about the parallel combination of resistors, but before that I just want you to just summarize this. Do remember that V potential difference is produced across these 2 points A and B, and R1, R2, R3 are connected in series between these 2 points. Okay, and there is a potential difference of V which is produced, and because of that what happens that I current is flowing through the combination. And when we substituted the values and solve it, we got the resultant resistance Rs equals to R1 plus R2 plus R3. I hope that this is clear to you.